Hi, this is a quick movie showing you how to perform a basic 3D deconvolution using AutoQuant. First thing to do is open ourselves up a file. We're going to use Mini 3-color as a sequence, and we'll get some information before we open it here. So width and height refer to the number of pixels. Depth is the number of slices in a Z stack. And then we also have number of channels and a time points here. So I'm going to go ahead and open that. And it's worth noting here, it'll open it as a maximum intensity projection, as opposed to viewing it as individual slices. As we can see here, we've got 27 slices, we can view them, or we can go for the maximum intensity projection that combines all those slices into one, and it uses, for every pixel, it will use the maximum value throughout the stack. Other things you might want to know quickly here are we can view the stack from the side like this, but we're mainly going to go from the top down XY view. So before we do a deconvolution, we actually have to enter parameters into AutoQuant. It's got to know a few things, and you do this by going into Data Browser. And as you see here, we have a few things to enter. It's actually already been entered with this particular sequence, because this information was saved in the sequence, and that may be for your images, but let's say it wasn't. You have the option here of entering the spacings, that's X, Y and Z values. Now the X and Y spacings will be the pixel size, so 0.1 micrometers in this instance, and the final Z spacing here will be the distance between the planes, so that was 0.2 micrometers here. We've next got information about the 3 different channels. You may not have 3 channels, you may only have 1, but we can choose the actual wavelength of the light, or we can just enter it manually, put nanometers. So I know the red channel was Texas red, in fact. So what have we got here? We've got the modality. Now that is referring to what kind of microscopy you used. So you've got a wide field or confocal options. Now in the AutoQuant trial demo that you might download, you actually get both wide field and confocal options here, but normally you would only buy a wide field or confocal package. So it's worth noting that if you buy the wide field package, you will get wide field, fluorescence and bright field. If you purchase confocal, you'll have the different confocal options here, and multi-photon fluorescence. So we know this was actually wide field fluorescence. Objective lens, 60, 1.4 numerical aperture, immersion, medium oil, that's alright. You click apply, and now we're ready to actually do some deconvolution. So we go to 3D deconvolution. We've got a choice here between the blind algorithms for the point spread function or the fixed. Most people here are going to want to use blind because they actually adapt themselves. There's a cycle, a series of iterations as the point spread function is applied to the sequence, and adaptive point spread functions actually improve themselves to gain generally a more accurate result. And you will generally want to use a theoretical one. That's just an estimate to start with. You could use a measured point spread function if you perhaps measured it from a series of beads, and then you could load the data set here, but we're just going to go for a theoretical one. Next thing, we have the option of using the default settings. Now you can play around with these. There are some expert settings, there are some more advanced settings here, but for this demonstration we really want to use the default settings. They're going to be fine. Some more options we've got here. We've got the options to show a progress window, and now that's as the deconvolution is happening, that gives you basically a live update of what's going on, and it allows you to see some of the processes that are happening. So we're going to have a look at that. Base name is the output file, so I'm going to leave that. You've also got the option here of saving a point spread function if you wish. Now to do the deconvolution, we click on this green tick here, but firstly let's just check that the settings are okay. They are, and this is the way the software is saying yes, you've got a valid image that we can do a deconvolution on. if we had, for example, put in an incorrect value here, maybe we put in 1000 instead of 0.1, and we had something that would create a completely bizarre image or something that wasn't feasible, it wouldn't say settings OK here, and it would not allow you to perform the deconvolution. But if it does, it generally means it's going to be OK. So we click go, and now we watch the deconvolution unfold. This is the progress that I was telling you about. You can see here it's deconvolving different channels, and if we go to view here and we go to display status, we can look in the status bar at the bottom and get a little update as to what's happening. So we're 60% through the deconvolution now, and at this point we can have a quick look at image enhancement. This is some information about all the combined channels. We can just look at individual channels here, and what we can do is some auto scaling. So if I go to all channels and click auto, what that'll do is it will boost the signal of weak channels. So if we have a weak red channel, it will actually increase the display. It will boost that channel to make it more visible to us. So if I click auto here, you can see, as I was saying, the red channel is boosted, and that's auto scaling. Now we can compare before and after here. We've got, I'm going to look at slice views from the original and a slice view from the deconvolved images, the deconvolved sequence. You can see here there's a lot more haze and a lot more blur here, and look at, you know, the improved resolution that we've gained here. Quite a clever little thing to do now is to actually sync both of these. So if I click the synchronization button, they're both in slice view mode, and now if we just use one of these slider bars, you can see it changes both the images to the same point in the Z stack, and we can see here that there is a greater resolution here, and a lot of that haze and blur has been cut out on the image on the right in the deconvolved image. So that's a basic overview of deconvolution. Obviously there's a lot more to it than that, but I hope that was helpful for you, and if you require any more information, please contact your local office or dealer. Thank you very much.